before I forget, I'm still fiddling here. What I'm noticing is that this resistor here is acting as a ballast for the spark gap. In other words, the more resistance I put here, now let me back up. The less resistance I put here, depending on, you know, other circumstances that'll also determine what will happen. But see, the problem is when I make changes to things surrounding here, like these coils or this capacitor or these capacitors, then I might have a problem in that the spark gap fails to fire, and then the surge just keeps climbing to infinite gain, and I get matrix's singular error message, and the whole thing blows up in my face. So the purpose of this spark gap ballast is to increase the likelihood as the resistance goes up. You know, the placement of the resistor here and the increasing of that value, that resistive value, increases the likelihood that the spark gap will fire more often rather than not at all or less often. So when the resistance is dropped here, the spark gap fires less often or not at all. And let's just take the case of less often. The less often the spark gap fires, the less often will the surge be dissipated, and that means the surge has more time to surge. And that's why when there's not enough resistance or no resistance, the spark gap doesn't fire at all and the surge just keeps going. But if there's sufficient resistance here, the spark gap will fire, and if you put too much resistance, it'll fire too often, and well, that's not really a problem, actually. That could be an advantage, because then the spark gap will be closer together. Your power level should come down. The peaks of the voltage and the peaks of the current of each staccato wedge will come down, but they'll be more closely spaced, I would imagine, which will be good for the rotor and stator to have the peaks come more often, the peaks of voltage and current come more frequently, so that you get less jerkiness when the motor wants to turn. You know, you sit in your car and one of those conditions in which you're thrust forward and backwards in your seat because the motor is jerking. It's not running smoothly. And so that's the problem with these staccato wedges, is if they're spaced too far apart, you're going to get that jerking effect in the car, and you don't want that. You want the motor to run smoothly. And so we want the staccato wedges to be compressed. I don't like them. They're not pretty, but that's actually the correct way to do this. And that means putting in a spark gap ballast in the form of a resistor here, and then raising it to a sufficient degree. There's no point in adding a capacitor because we already have that in parallel with the spark gap to help it to fire. But also change these capacitors, in particular this one, but also the other three act as support. This one helps change the ratio of amps to volts. The problem is it also changes the frequency, but more importantly, it changes the likelihood that the spark gap will fail to fire. If I increase the capacitance here, it'll be less likely to fire and more likely to go to over-unity and blow up the circuit. So when I reduce this to try to improve, you know, raise my amps and lower my volts, when I raise this, the capacitance here, to raise my amps and lower my volts, then I run the risk of the spark gap not firing, because this is going to be less likely to dump the energy that it stores, less likely to discharge. Instead, it'll want to keep charging to a higher value. That's what capacitance does. And that means that when this is less likely or less frequently will it discharge, that means it won't help the spark gap fire. It'll hold it back. It'll actually hold it back. So this is a regulating mechanism for when the spark gap fires, but it also helps modify the amperage to voltage ratio over here. So it's a lot of juggling act between all these different effects of these things working with each other. And if I have problems, usually what I find what solves the problem, if I, going around in circles, keep trying all kinds of variations, because I don't know what I'm doing. I can't plan ahead and do equations. I'm letting the simulator do the equations for me, but that means I don't get to plan ahead. I just bumble my way through this. But usually what I find is I need to add another component somewhere, or rearrange components, usually add one in order to give me more flexibility if I find myself running around in circles, bureaucratic circles, so to speak, in which I'm not getting the results I want. I'm not going to, if I have a target of a certain behavior and a certain output, I don't have to worry about the input. Then sometimes I feel like I'm being given the runaround, and I'm not getting the job done that I had set for myself, the task that I had set for myself. So that's why I added these ballasts here and here. That helps stabilize things so that I can take things in the direction I want to move it in, because this circuit wants to blow up. The whole point of electricity is it's a wild stallion, and it wants to blow up in your face, create a bonfire or a wild forest fire that's out of control, raging out of control. Like the Malibu fire back in the 91 or thereabouts, 89, 100-foot flames. It was outrageous. The dry tinder situation, it was outrageous, and Santa Ana's, fanning it. And that's what electricity is when we start to investigate the nature of a surge. It wants to be wild and just blow up. It's literally an electrical bomb. It's actually the electrical dynamics behind explosives. So if anybody bothered to study the electrodynamics behind an explosive instead of just focusing on the chemistry, this is what they would see. And then remove the chemistry and replace the chemistry with a circuit. This is what they would see. We want to create an explosion, but we want to do it in a controlled fashion so that we get just the amount of power we want in the way that we want it, and no more, no less. And not be erratic either. It needs to be consistent, periodic, something our appliances can depend on, and we don't have to freak out when something weird happens. But it's literally, I should rename this, not surges or whatever else I was calling it. I should call this the electrodynamic study of explosives, because that's literally what this is. Paul Babcock and Peter Lindemann would agree, the universe has governors. Mother Nature puts governors in place to prevent the universe from blowing up, because the nature of electricity is to blow up. And then I'm trying to bypass those governors, but still put some back to make sure it does not blow up completely. Just a little bit of blow up, just a little, to give me over unity. So I think that says it very clearly. So that's why we have to call these resistors ballast. They're our friend. They help stabilize what's going to surge and blow up in our face anyway, because we got this 4-diode bridge feeding a capacitor over to the side here. And so this area in here is going to blow up anyway. And then we put in a spark gap to help alleviate the surge condition once in a while. A little tiny leakage, literally a leakage of energy in the form of microwave radiation that has to be grounded out with a proper protection surrounding the spark gap, so we don't get irradiated with microwaves and end up producing mongoloid children. But hey, it's not age of the man that does it. It's simply the bombarding the gonads, the testicles of a man, with microwave radiation over a long enough period of time, even though it's low grade, and then he ends up with mongoloid sperm. No good for making children. So it's very important to shield ourselves. And also there's the other problem. Chris Bake is getting rheumatoid condition in his knuckles because he doesn't shield himself from all the sparking, according to Byron Brubaker, his friendly critic, his critical friend, or whatever, however you want to put it. Hey, somebody's got to be the supervisor and the quality control supervisor, OSHA, hey, Byron might have been You know, because that's what OSHA does, right? It's safety first, or else you won't end up working very long if the safety goes out the window. Anyway, I better stop talking and go back to work. This video is getting very long. I may have to split it up into parts, which is okay. I can do that, just as long as you understand and don't get bored.